The overall goal of this procedure is to produce platinum-based extended surface electrocatalysts that demonstrate a high level of performance and durability in the oxygen reduction reaction.
This method can help address key issues in hydrogen fuel cells by reducing the amount of platinum required and cutting the cost of the catalyst layer. The main advantage of this technique is that it produces materials with high electrochemical surface areas, a traditional limitation of extended surface catalysts.
Begin the nanowire synthesis steps with the displacement process. In a 50 milliliter centrifuge tube, add 20 milliliters deionized water and 40 milliliters nickel nanowires. Place the mixture in a sonicator and sonicate for 5 minutes. Meanwhile, prepare a mineral oil bath and an electric stirrer. Retrieve the suspended nanowires from the sonicator and transfer them to a glass 250 milliliter round bottom flask. Add to the flask 60 milliliters of deionized water. Then place it in the mineral bath to be heated to 90 degrees Celsius and simultaneously stirred at 500 RPM. Equip the stirrer with a PTFE paddle on a glass shaft. Now form the platinum nickel nanowires. Have ready an automated syringe pump and prepare a syringe. Use a 20 milliliter syringe with about 8 centimeters of tubing on its tip. Next, obtain 15 milliliters of deionized water and add 8.1 milligrams of potassium tetrachloroplatinate.